Hey guys, have you ever wondered how those amazing AI chatbots like ChatGPT can answer questions about things that happened way after they were created? It's not magic, it's a super cool technique called RAG, or Retrieval Augmented Generation. Think of it like this: an AI is a super smart student who has read a ton of books. But what if you ask it a question about a brand new movie that came out last week? It wouldn't know anything about it because it was trained on old information. RAG is like giving that student a personal librarian. When you ask a question, the librarian, the retrieval part, quickly scans a whole library of new information, like the internet or a bunch of documents, finds the relevant facts, and hands them to the student. Then the student, the generation part, reads those facts and uses its own smarts to give you a perfect answer. It's the best of both worlds. But here's the problem: that library of information can be messy. Imagine a giant 500-page book with no chapters, no paragraphs, and no index. If the librarian has to find one specific detail, it's going to take forever, and it might even miss the most important part. That's why we need to organize our information by chunking it. Chunking is just a fancy word for breaking down big documents into smaller, more manageable pieces so the AI can find exactly what it needs, quickly and accurately. It's like creating a super organized digital filing cabinet for the AI. Let's dive into some of the coolest ways we can do this. Basic and straightforward chunking. The simplest way to chunk is like a brute force approach. The first one is fixed length chunking. This is the most basic strategy. You just decide on a specific number of words or tokens, say 500, and cut the document into chunks of that size no matter what. It's like taking a long essay and cutting it into equal 5-inch pieces with a ruler, even if a sentence gets cut in half. It's super easy and fast to do, which is why it's a go-to for simple documents like FAQs or technical manuals, where the text is pretty consistent. But yeah, you can end up with half-finished sentences, which can be a bit awkward and might confuse the AI. A smarter step up from that is sentence-based chunking. Instead of cutting at a random length, you only cut at the end of a full stop. So the sun rises in the east, it sets in the west, would be two perfect chunks. This is way better for things like legal documents or medical reports, where every single word and sentence is crucial. You wouldn't want to break a legal clause in the middle and lose its full meaning, right? Then there's paragraph-based chunking. This is even more intuitive. You just treat each paragraph as a separate chunk. It's perfect for things like articles or essays. A paragraph usually contains one main idea, so when the AI retrieves it, it gets a complete thought unit, like a mini chapter from a book. It's much more logical than cutting mid-sentence. Smarter chunking strategies. Now let's get a little more advanced. What if important information gets split between two chunks? That's where overlapping window chunking comes in. Imagine your chunks are 500 words long. You can make them overlap by a small amount, like 50 words. So the first chunk is words 1 to 500, and the next is words 450, 1 to 950. That way, if an important sentence is at the very end of the first chunk, it's also at the beginning of the next one, so you don't lose that crucial connection. This is a lifesaver for things like story transcripts or meeting notes, where the context flows from one part to the next. Semantic chunking is even cooler. Instead of just chopping text based on length or punctuation, we use AI to understand the meaning. We tell the system to find where the topic changes and create a new chunk there. For example, in a long article about climate change, it might start with causes, then talk about effects, and finally discuss solutions. Semantic chunking would keep the causes section as one chunk and the effects section as a separate one, even if they are different lengths. This is perfect for complex knowledge bases, because when you ask about effects, the AI gets a whole meaningful block of text just about that topic. Structured and specialized chunking. What about documents that aren't just plain text? For documents with tables, bullet points, or lists, we use table and structured data chunking. You don't want to cut a table in the middle of a row. This strategy keeps entire tables or lists as a single chunk. It's perfect for things like financial reports, restaurant menus, or technical specs, where the structure itself is part of the information. Imagine asking a bot for the prices of desserts, and it gives you a chunk that only has half a table. That would be useless. A more advanced version of the overlapping window is sliding window with semantic weighting. It's not just about overlapping, it's about being smart about what you overlap. You can tell the system to prioritize important parts, like headings or key phrases, making sure they appear in multiple chunks. For instance, in a troubleshooting guide, the section titled "How to Reset Your Device" is super important. This strategy ensures those specific instructions are always in a retrievable chunk. Multi-level and entity-driven strategies. Sometimes one level of chunking isn't enough. That's where hierarchical chunking comes in. This is for really big documents like textbooks or large manuals. You first chunk the whole book into big sections, like chapters. Then, you break each chapter down into paragraphs. And you could even go further and break those paragraphs into sentences. This way, the AI can search at different levels of detail, depending on the question. If you ask a broad question, it looks at the chapter chunks. If you ask a specific question, it drills down to the sentence chunks. Keyword or entity-based chunking is all about identifying key terms and building chunks around them. In a legal document, for example, the words plaintiff, defendant, and judge are crucial. This strategy ensures that any section of the text discussing these entities stays together as one chunk. This is amazing for specialized fields like law or medicine, where specific terms are the main focus of the document. The best of both worlds and beyond. Since no single method is perfect for everything, people often use a hybrid chunking approach. This is where you combine a few strategies. You might use semantic chunking to divide a company handbook into big sections like HR policies and code of conduct. But within each of those sections, you might use fixed-length chunks with a small overlap to keep it efficient. It's a flexible approach that gives you the best of all worlds. And we're not done yet. People are always coming up with new ways to chunk information. Metadata-aware chunking uses the document's own tags and labels, like author, date, or section titles, as natural breaking points. If a user asks, "What did the abstract of this paper say?" the system can go straight to the chunk with the abstract metadata tag. It's a great way to make retrieval super direct and precise. For conversations, we use conversational turn-based chunking. Instead of cutting a chat transcript in the middle of a sentence, we chunk it by who is speaking. So everything person A said is one chunk, and everything person B said is another. This keeps the flow of the conversation intact, which is super important for chatbots and customer service logs. Visual or layout-based chunking is used for things that aren't just plain text. If you have a PDF of a presentation, you can chunk it slide by slide instead of by lines of text. This is a game changer for things like instructional guides or slide decks, where the visual layout itself tells a story. Finally, for things like FAQs or help centers, overlap with question-answer anchors is perfect. You simply make the question and its corresponding answer a single chunk. So Q, how do I reset my password, and its full answer become one unit. This makes it incredibly easy for the AI to retrieve the correct answer when someone asks that question. So in the end, it's all about context. The right chunking strategy can make a good RAG system great. If your chunks are too small, the AI loses the bigger picture. If they're too big, it's like trying to find a needle in a haystack. But if you choose the right method for the job, whether it's simple, semantic, or a clever hybrid, the AI can grab exactly what it needs and give you a response that is spot on and makes total sense. It's just like how a librarian organizes their books. The better the filing system, the faster they can find what you need. And in the world of RAG, our job is to be the best filing system designers we can be. Pretty cool, right?